Many thanks for inviting us to this conference, to this meeting event. It's very nice to be here. I heard some of you making comments after the Russian session that with all the sanctions in Russia, Kazakhstan represents a bright spot in the region. It's very encouraging, and I think it is true. Even though we're not immune from what's happening in Russia, but I think we continue to be an attractive and interesting place for investments. Alexei also mentioned that not much exploration has been done since the Soviet times, and I tend to agree with it. We are working on what has been explored in the Soviet times, and if you look at, for example, gold companies in Kazakhstan, you won't find many new plays. Everything is very well known, explored, developed, and it is often difficult to find something unique. But I think we found it. Verne Capital, just a very brief about us. It's a private equity firm out of Kazakhstan with an anchor investor, Mr. Bulat Muratov. You probably heard of a few of our large transactions which we've done in mining. It includes Kazzinc, which we exited 3 years ago through Glencore. We have also developed a Vasilkovskaya gold mine since 2006. I think we entered when the gold price was at a very low base. Invested more than $700 million into it, into a large producer in Kazakhstan, effectively. And we sold it to Kazzinc in 2012. I think it was a very good timing for the exit. What we have done since then in the mining, we have acquired a company, maybe some of you have heard of a company called CAMEX. The transaction happened in 2013. The company had 2 licenses, blocks, one Komarovskaya field and another one is Raigorodok. We bought that together with Kazzinc. In fact, we participated 10%, they at 90%, and then we decided to split up. We basically let Komarovskaya sit in Kazzinc, and we took the Raigorodok to our balance sheet. What is Raigorodok? It's a junior gold producer in Kazakhstan with very high exploration and production potential. This year we produced 1 ton of gold, and it's all heap leaching. It's oxide ore. There are 2 open pits, the South Raigorodok and North Raigorodok. You can see our cash cost is very attractive. Currently, the reserves, what we estimate at under GKZ is over 1 million ounces of gold, and we expect conservatively that by 2017 our reserves will stand at 2.8 million. We are preparing ourselves for JORC compliant reporting, and we're doing the things to help that. We have also very promising results for the primary ore processing. It is simple to process, and it's very much suitable for carbon in leach treatment. Location-wise, it is not far from Astana, in this very interesting major gold belt where you see other gold players in Kazakhstan. It is just under 70,000 square meters of the size. As I said, there are two open pits, north and south. We have exploration license till 2017, and I think we should be fine to complete the work by the deadline. We won't need to extend. And production is until 2021, and that we can clearly extend upon the need. Basically, just to focus on 4 key elements to the company which we're developing. Number 1 is we think it has a lot of potential in terms of resource increase. We are also growing in production. We doubled it this year, basically, and we are continuing to grow the production. We think it will grow over the course of the next 2 years. I think we have assembled a very strong local team, and I will introduce you to it later during the presentation. And the company is self-sufficient financially, which is great in our times. It is paying for its own exploration and development works. If you look at this table with resources, you will see that the company is extracting oxides with average grade of about 1 gram per ton. At 1.3 million tons per year extraction, the amount of current oxides will last for 6 years. So we're good for another 6 years before we need to put the treatment plant in operation. And we're hoping to extend it to 12 years, really, with our ongoing exploration works. But the key resource increase is coming from the primary ore, as you see it there, and the grade is more than 2 grams per ton that we expect. The license area is well explored. Ever since opening the field, more than 1,000 diamond drill holes have been drilled. They constitute more than 150,000 meters, and almost half of them been drilled after 1996, when the company was given license for the area. Nowadays, main exploration works are done in the south part of the area. The area of current open pits has been substantially explored through core drilling and reverse circulation drilling, and we plan a lot of additional drilling in 2016. This is North Raigaradok. As I said, license has 2 fields. So this is north. It is this year extraction from the open pit was more than 800,000 tons of ore. The 3D model shows resources as of 2008. This is fairly old. It doesn't show the results of the latest exploration works, but we are working on updating it, and we soon will be issuing it for the public domain. South Raigaradok is where we see a lot of promise and a lot of growth. We expect the resource of this mine to be about 1.6 million ounces. This year we started the work on South Raigaradok, and we extracted about 400,000 tons. And it has also been our main exploration area for the last 2 years. Thanks to that exploration works, we expect to add another 840,000 ounces of gold into resources. If you may see on this slide, most of the increase in gold will be coming from flanks and from the deeper horizons. 2015 was a busy year for the management. As I said, we started the work on South Raigaradok. This year we have built a second crusher and agglomeration line. We modernized and expanded H&P, and we built new heap leaching area. Technological tests show primary ore is low in sulfides, which is good news, and our tests show that the recovery rates could be up to 93–95%. CIL, as I said, is a suitable process for the primary ore with good recoveries. Oxides can also be processed on CIL. In our opinion, that's probably the way we will go. And with the better recoveries. And we expect that the future capacity of the plant will be 2 million tons per annum with 130,000 ounces of gold per year at 2 grams per ton. That's our plan. As I said, we have a very strong local team. Serik Sazdikov, who is with me and here in our room, I'd like to encourage all of you who are interested to know more about the company to meet him personally. Serik, поднимись на секунду. Serik has very extensive experience in mining. He worked at Celtic Resources, Eureka, and in Kazakhstan Prom as the latest positions. As I said, our financials are very solid. There is no cash drain on burning capital. Company is able to finance their own exploration works, and with a sustaining cash cost of 720 per ounce, RG Gold is financially solid. There's a few pictures of what have been built this year. You see the conveyors there, the H&P plant, and the power lines which we built, and a very nice man camp for very happy workers. Okay, thank you very much for your time. Happy to answer any questions you may have.
Do we have any questions to go around?
How much drilling do you anticipate before 2017?
We expect to complete our drilling program by August next year, and then we will take the remaining period for interpretation and building the 3D models, etc. So our drilling is ongoing right now, and it will not stop as we go through the next year. The total number I would not be able to tell you right now, but I would be happy to come back to you with the exact numbers. But it's extensive. I think the budget for next year, сколько мы планируем?
Следующий год у нас порядка $4 миллионов.
About $4 million for the drilling, investing. Yeah?
Any good ability to extend your exploration period beyond 2017?
Yeah. And actually, we are considering to do that because we've done our geophysics, and we see that there are interesting extensions to the field, which are very prospective, adjacent, and we're considering to expand the area. That's true. It's too early to say though, but that's the thinking. More questions? Я переведу, да.
Ага. Значит, ну, на сегодняшний день результаты разведки показывают, что мы не оконтурим полностью наши рудные тела как по простиранию, так и по глубине. Практически с учетом этого мы считаем, что потенциал этого месторождения ну, близится уже к 100 тоннам примерно.
Yeah, I'll try to translate. Basically, based on the exploration work we've done, we realized that we did not define yet the whole prospects of the fields, and the potential which we're looking at is to bring it up to 100 tons of gold in reserves.
Yeah, just one question. What's your exit strategy? You're going to, Burning Capital is going to operate this, or are you going to look to sell or list or what?
Yeah, thank you for that question. We're fairly open to various options, right? Yes, we are private equity, and by nature we are not a strategic player who wants to keep it in our portfolio for a very long time. But we think, though, there is a lot of things to add value at this point before exiting. So we will continue with the exploration. We will add as much reserves as possible. We will propose a technology to develop it further. If there would be an interest, we would be happy to consider it from outside. If not, we've done once with Vasilkovskaya, and very successfully. We are comfortable to continue with the same experience and the same team. Okay.
Yeah.
Thank you, gentlemen, ladies.
Thank you.
Thank you.
So,
Thank you very much. Just a couple of remarks back to the panel conversation. I was the CEO of Hambledon Mining PLC, and I lived for 3 years in Uska-Minogorsk, or actually I lived in Sekisovskoye, just near there. So I have a degree of knowledge, and some 10 years ago I was the technical director of mining for Wardell Armstrong. So during the boom period 2004 to 2008, I covered just about every property there was in Central Asia and Russia. And I'm a bit of a fan, like Mr. Nick Clark, of the region and of Russia, and I have a very strong view about the positive nature of the place. And for Roz, if you have a chat with Mr. Blair, he'll give you an idea about the opacity of Central Asia, or if you'll buy me a glass of wine, I'll point you out a couple of things in that regard. AMEC Foster Wheeler has a strong relationship, just like David, with SRK, with the modernisation of the states within Russia and Central Asia. And the chairman of CRISCO is an AMEC Foster Wheeler geologist, and we have a number of our senior technical staff involved globally in modernisation of state geological classification systems. So at a technical, and operational level, we do bring a lot of strength technically, like SRK with David, to helping states reform their sector and bring together the state and the entrepreneur so the two may work as best in harmony in this regard. I'm going to change the theme a little bit, and I'm going to deliberately talk about how to make more cash from your business, how to be smart at mining and improve that cash flow. There's quite a few slides, so if you'll excuse the plain speaking, I'm going to go through this fairly quickly. If you can't keep up and you have a question at the end, then we'll go for it in that regard. Okay. Safety is very important to AMEC. Every single time we meet, we talk about safety. I'm not going to spend a lot of time labouring a safety moment, as we like to call it, but everything we do is very important from a safety perspective. We hold that as a very strong core. We're over 40,000 people, whether we're building a $7 billion mine in Western Australia, or mines in Namibia, or Sakhalin 2 oil projects, or nuclear submarines. It's every single person in our company goes home safe every day. And I know we don't talk about safety at conferences much, but it's a very important principle to us. So, smart and clever mining. I look at this as one thing. How do we counter value leakage? If you're a CEO of a business, I've been there, much like a few of the people in the audience, you're trying to make sure that you maximise margin and contribution. Revenues, costs, and how do you have real-time information to make this business work? So, I look at this from how do you make objectives, how do you set them, and how do you balance projects. We start off with the prospector, the guy that likes to lick rocks and walk out in the bush. We then have a guy who's got to work pretty fiercely to get the construction together, the bankable feasibility studies, convince the bankers, convince the state they're going to build this wonderful project. Once it's up and running, we want to change to having someone who's going to fine-tune this business, someone who knows how to tinker and look at things carefully. I'll call him the farmer. So, why should we have smart mining in today? I'm sure you don't have to read the FT to work out that there are macroeconomic issues, that we've got low metal prices, and we heard in the Russian presentation, despite the devaluation of the ruble and the tenge, we still have very high operating costs, and a lot of companies are struggling to generate cash. Those of you who have the privilege of running a mine know that you've got half a dozen issues that are related to this. The gentleman before talked about going from oxide to sulfide, immediately harder ore, more difficult processing, much more expensive. Heap leach might cost you $1 or $2 a tonne, CIL costs you $8 to $10 a tonne. These are what I call the operational headwinds which impact you making cash. So what does smart look like? So this happens to be a different sector that's predominantly feeding the Chinese iron ore. I hope you can see from the diagram it's about making structural changes to your cost base so that you understand exactly what you're doing in terms of generating cash. So I'll go through a few areas, a little bit of detail, as they say, is how we're going to make these things better. So if you're a drill and blast in whatever, open pit or underground, how often have you measured what you plan to do in the engineer's office and what actually happens in the open pit? How often do you measure fragmentation? I know that some of you aren't technical people, but have you actually asked your engineers, tell me how you measure fragmentation? Do you have haul roads that are goat tracks, or could you drive a four-wheel drive on it? Have you actually been on top of a waste dump and seen where the longest period for your $1 million truck is spent on that goat track called a waste dump? Okay, it's just waste, isn't it? It's just over there. But the trucks spend more time on there than in front of the excavator. Have a think about that when you ask your engineer how you're running your mine. Payloads. Are your trucks full every single time? How often do they wait at the trucks? How often have you sat down and looked at automation? How do I improve these $1 million machines? How often have you thought about grade control, for those of you who understand the topic, as a value-based system? How have you thought about recovering the metal rather than just understanding what the metal is? Have a think about what I'm trying to say there. How often do you recover it and think about it rather than just studying it in that regard? Have you measured grade control with things like hardness, impurities? How does it go through the process plant rather than it's got a certain gram per tonne in it? An ore body isn't just an average model. The gentleman before talked about, I've got 1 million ounces. Are every one of those same ounces exactly the same mineralogically? The answer is no. So how do they go through the process plant? You have to think about this on a day-to-day basis. Let's talk about an underground mine. Really, an underground mine is all about choreography. Drilling machines, all these different machines in all these different tunnels in the right place at the right time. So have you asked your engineer how often he measures when those machines are in the right place and how often they're in the running in between space, between getting from the right place that was meant to be at 6 o'clock in the morning and at 8 o'clock in the afternoon? Are they at the right place or are they in between? How often have you thought about balancing your production teams with your support teams? Have you ever measured when the ventilation guys are in there making sure there's underground ventilation, or are you more focused on tonnes? Because it actually could be the ventilation that's impacting on getting those tonnes out of the mine. Theme of mine, goat tracks or highways. Are your underground roads around the grizzlies, backing up to the crushers, at the draw points? Are they goat tracks or are they proper paved roads? Are you tearing up tyres, breaking transmissions? Have you stood and looked at that? So I'm going to give you just some examples to try and build on some of that theory. So have you looked at changing the stope size to reduce your operating costs? Have you looked at changing the way you develop and sequence the operation so you can get to higher grade ore quicker? Have you modelled the traffic flow of all these different pieces of machinery. An underground mine, I'll pick a Kaz zinc mine near Ruskamenagorsk, may have over 110 pieces of moving equipment. So that's 110 drivers. Have you ever known 110 cab drivers to get it right every time? Because that's what's going on underground in your mine. And I can assure you, they're doing different things than what you thought they were doing. So you need to understand where those 110 drivers are every hour of the day. So that brings me on to one of my favourite subjects, which is machinery. Lots of engineers like to measure availability and utilisation. How do they measure that time? Are they using the 365, 7 or 24? Or do they go, oh, actually I've only got 20 hours in the day because the rest of the time they're at home. So utilisation and availability are very different than the reality. The Caterpillar people think you can run a machine 365, 7, 24. What are you running it? And how do your engineers measure what you think they're telling you? Okay? Have you actually sat down and looked at the back of the workshop, there are the tools and the filters and all the spares to maintain that equipment. Is it optimised? Are you actually measuring what's going on at the back end of the workshop and the warehouse? Fuel. Those of you who've operated in Kazakhstan and Far East Russia, those of you who haven't and are about to enjoy the experience, I can tell you the fuel is, and there are ladies present so I won't swear, is poor. It's full of sulphur and particulates. Last time I checked, the Caterpillar engine's meant to last, say, 12,000 hours. Try 2.5 in that part of the world. Why? Because the fuel's of very poor quality. You need cleaning equipment. Lots of people think, oh, I'll just buy some cleaning equipment. It doesn't work when it's minus 35 degrees. You need to understand the detail of how you're going to run a mine. We've talked about costs and running machinery. Now let's talk about how do we enhance our revenue, okay? So processing stability. I have one thing I always like to say to people. It's January, Far East Russia and it's Kazakhstan. Usually we're in the minus 30, if you're lucky, minus 38 degrees. It's 2 p.m. on the back shift. And the grade coming through the crusher into the grinding mill, there's a 2 or 3% variance. That's not very much. And then the recovery's 2 or 3% different. So all of a sudden your back-end process has got to deal with a 4 or 5% change. Have you over-designed that, under-designed it? Do you even know what's going on? Anyone who thinks that the production report you get in the morning at 7:30 when you're the general manager, last night's shift was 88% recovery, go and look at it every 10 minutes and I can assure you it looks like a sailing boat going from 70 to 90. Are you really measuring and understanding what's going on in your process plant? Okay? Because it's not an average of 90. I can assure you of that. Do you understand how the hardness changes, the grade, all of these factors? Do you understand what it's going to be like to run through the crusher in a cold day compared to a summer's day? That machinery operates very differently. When we look at, I've picked 3 examples here. Coal. Do you understand when you're selling coal to a customer how the price that is paid changes on low-level impurities? Does your process plant measure them, or are you just focused on tons of coal because that's what's driving the revenue? Or are you focusing on, pardon me, what the customer pays you? Copper. It's all about value and use. How many copper mines, and I'm going to look at the lady from Kaz Minerals, measure slag to copper ratio? Because I can guarantee you that'll mean a 10% change in your copper concentrate. Ask how many site managers are actually managing that particular key ratio. Iron ore, it's all about logistics, as I showed in my smart mining, what does it look like, and you can see what those businesses have done. So looking at your supply chain is fundamental. So what does it look like? I'm going to rattle through here. Okay, so in Canada, how do you get more consistent head grade to the mill? We aligned maintenance shutdowns with periods of low ore zinc production. So it's getting the mill and the mine to talk to each other. All of these case studies are examples where AMEC Foster Wheeler globally has brought about cash generation improvements to individual mine sites. How have you managed the services in the underground mine to make sure that every one of those machines, those 110 cab drivers, are at the right place doing the right things? Have you understood how to maintain all of that equipment? The much unloved cyclones that sit behind the mill, the grinding mill on that tower, that you think, what do? They're not stirring tanks. Have you actually looked at how those are maintained and how that impacts on the overall cycle and recovery of the process plant? Have you looked at understanding how fines impact the whole processing circuit after the grinding mill? Because that's what the cyclones are doing. If you haven't got the cyclones well maintained, you've then got a fines problem. I won't bore you with why fines are a problem. Ask the metallurgical guys on site. Waste dump location, one of my favourites, and one that I know David has done a lot of work on in his business as well. If you can change the stripping costs, change the waste dump location, you can fundamentally change your operating costs in an open pit mine. This one mine managed to save $6 million a year just by moving the waste dump and making sure the top of the waste dump wasn't a goat track. Here's a thought. When you're looking at your concentrator or your mineral processing plant, are you looking at dollars per hour output or are you looking at tonnes of concentrate? Have a think about the difference. One's tonnes, one's dollars. You're all about revenue, not about tonnes. Okay, large open pit mines, so drill and blast isn't expensive. Have you looked at optimising drill hole spacing? Have you sat down and asked the engineer, what is the spacing and why does he use it? Does he measure fragmentation or is it just something he inherited from the previous engineer? When we're trying to send material from the open pit or underground mine to the process plant, we want homogeneous. We want to give an even feed to the process plant. Are we doing that on the ROM pad, okay, where we've got a small amount of area in front of the crusher? Or have we had an opportunity of thinking about it doing in the pit? And where's the value saving in terms of operating cost per hour and operating cost per tonne? When we looked here at this business, we sat down and we said, how can we actually change the entire value of your business? We went back to brass tacks and said, it's operating, but let's redesign from the beginning. We looked at the whole overall pit design. Here's just a couple of other ones. And again, I'm sorry for the change in formatting. I'm an engineer, not a PowerPoint publishing person, so apologies in that regard. We brought about an open pit grade control system that changed at one large copper mine $50 million worth of annual revenue, just by looking at the way the grade control system worked. It's a nice picture. It shows you how difficult engineering can get in some of these difficult projects. Northern Far East Russia has similar problems, and you have to therefore wait until the harsh winter of February to be able to bring in on the ice roads material, although this is a particularly different one. Following through, AMEC Foster Wheeler not only designs, does pre-feasibility studies and helps with the funding of projects, we actually build mines. We changed the whole EPCM contract for this particular mine and we're able to bring it on time, under budget, in quite a demanding situation. A famous mine that we've all heard about recently, we did some trade-off studies here and we enabled a reduction in complete capital expenditure by Rio Tinto. We re-looked at the feasibility studies before the company went to build this particular mine in Canada. It is a similar climatic condition as Far East Russia and Kazakhstan. And we were able to change the whole operating and capital cost structure by just sitting down and working through the feasibility study from a practical point of view. Here, we sat down and we looked at some trade-off studies. CIL, CIP, or should we turn around and change it slightly to having some adaptations on the process side, focusing constantly on revenue enhancement and cost focus on a capital point of view. This particular project, we turned around and changed the whole front-end engineering design. So we took the feasibility study, started doing the drawings for the construction team, and changed the design around with the owner and enabled a significant reduction in capital cost and the EPCM contracts. We looked at the mine feasibility study, changed the drill and blast and got the OPEX down. Beg my pardon. Here we rearranged the entire EPCM contract structure, under time, under budget, construction completed. Escondida, again, brought about a different way of taking the feasibility study into construction and enabled an under budget realisation of that project with the bioleaching, which was a novel feature of that project. We have within AMEC Foster Wheeler a unique copper facility, and we were able to bring in within a copper CIL project the first use of POX, pressure oxidation technology, for the treatment of copper concentrates. POX is fairly well known within gold, not well known within copper. It's a strength of one of our technology teams. This innovative design is patented and enables us to improve customer revenue. Moving out to the desert countries of Saudi Arabia, we own within AMEC Foster Wheeler one of the world's largest machinery companies for the provision of heap leach stackers and conveyor systems in this regard. So it's a fairly large system here for the large phosphate development program with Marden, and we delivered this on time and on budget. A project which we're currently finishing off is the Roy Hill project in Western Australia, 7 billion. Not only did we do the feasibility, engineering design, managing the construction, we're actually helping build that. So we've got that detailed crossover from the very beginning of a project to execution. We changed the way the plant was going to be built, went and had a lot of it constructed in Perth, modularised, brought it on site. We halved the on-site construction team. And there are a number of these kinds of examples that have been repeated, whereas why build it in the Far East and in these difficult climatic conditions when you've got a short summer period, looking at building it where you can get it done within a good facility and then bringing it modular to the site. What's the team that look like that can do smart mining? So kind of a bit of a sales pitch here, I'm sorry about that. So essentially this is what AMEC Foster Wheeler does, everything from geology through to mine building. So as I said, concept through to closure and improving cash generation. We have the normal front-end consulting which deals with writing competent persons report, 43 101s to raise capital, feasibility studies for board sanctions and development programs to improve cash. Resource estimation, we lead the world in our geostatistics field and in general all over the world, much like many other consultancies, we can assist with exploration and development programs on geology. Open pit mining, we've been working on Bingham Canyon, so some of the biggest projects in the world, similar to the Russian colleague who was talking to us this morning, to again some of the smallest businesses around the world. Within open pit mining, we optimise value with cut-off grade, phasing strategies, and looking at how this works to improve cash. Mineral processing, again, because of our strength in plant construction, we have a very strong mineral processing team and infrastructure team here in the UK and in globally. One of our key areas of strength is in geometallurgy. It's that 2 p.m. January question, how do you make sure the mill is processing what you think it's going to process and how are you going to measure it? Complex copper ores is a unique speciality of the AMEC Foster Wheeler team. We have a number of global patents and we work with all the major businesses from Freeport, Rio Tinto, BHP on improving all of their major copper projects. Underground mining engineering, very sort of generic sort of phrase there, but we do cover some of the biggest underground mines, Rio Tinto in Mongolia, Freeport, and some of the very deep and large mines in Africa. One of the things that we do focus on is integrated underground mine development, and this is looking at dynamic simulation modelling, what I call in plain language choreography. Those 110 people go to a big mine, you may have 350 pieces of equipment moving. How do you make sure every single one of them is doing what you want it to do? Smelters and refineries, we've designed them, we built them, we help maintain them. And debottlenecking within a smelter is one of the key facets to improving revenue generation. Again, asset support, we assist a number of clients from the majors to the small groups in debottlenecking and also understanding the logistics of getting products from mine, port, smelter and to customers. Material handling system, as I've described, we own the business, we understand the costs and we can implement it globally. For those looking at M&A activities or including bringing in extra capital, due diligence, financial analysis, that's very normal in this regard. Again, modularisation and being able to design, build, whether it be an oil platform, mining, nuclear submarines, we can do all of that. One of the key facets that we bring, and I want to labour 2 or 3 key points here, is one of the things we look at is zero-based design, making sure we go back to that plain, what are we trying to achieve concept, and start with that to help clients, whether it's an operation or at the feasibility stage. And then there's a key point here. What we're trying to do is make sure that your capital intensity is aligned to shareholders. Okay, there's a cycle there from conceptual studies to running an operation, how have you matched your capital intensity to what the shareholder and the financial institution is looking to bring to this project? And the key area where the majority of this value is brought is within the pre-feasibility study. Once it's up and running, there's a little bit you can do. A lot of the innovative thinking is in the PFS stage. And this is a key area where we try and work with clients and try to maximise value. Thank you very much for listening. I know I've covered a fair bit of ground there, but I hope that it's been useful and given you some insights and some examples of where smart mining can improve cash generation in your business. Thank you very much.
Thanks, Steve. Perfect timing.
Just. Any questions? Oh, thank you very much.
Can I just ask
Oh.
one question? This goes back to Andrew and I on the panel just now. In terms of dealing with, say, the Central Asian CIS as an issue of bringing on board design institutes for adaptation of your design, how do you integrate that process to your design engineers, say, in Kazakhstan?
We've had some success. MINEX Eurasia has a design group in Kazakhstan registered. So that's one experience. We have nearly 400 people there and we work in one particular sector. When I was a director of Wardell Armstrong, we actually set up a local office in Almaty and worked there. And when I was the CEO of Hamilton Mining PLC, we actually brought internal to the company a very strong legal team, and we actually became an internal design institute. So I'm not going to give away all the secrets I know about how to do things in Kazakhstan, but there are a number of ways. How do we do it at the moment? We have a strong link with a number of the design institutes, Usk-Menogorsk and Karaganda and other places, and we would partner, much as you described, by bringing Western expertise alongside a local design institute, using a couple of key people in country who've managed studies, who say former directors of design institutes, so that we close the loop. I think one of the things, if I can call it a trick of the trade, if you're engaging with a local design institute at, say, feasibility level, look for someone who's been the general director previously and has moved into a more entrepreneurial field, and they can help you interface between what a Western consultancy is doing and the local institute. And they will bridge the entrepreneurial misunderstandings that sometimes chief engineers in these design institutes have. So there are some nuances as to getting this to work. But Alexei said it right. One is a state system for permissions, one is an entrepreneurial risk-based system, and it's trying to merge the two. And you just need to know how the systems work to get them to work in that regard. Does that answer the question, sort of?
Yeah.
Any other questions? Thank you very much.
Thanks, Steve.